Hello, everybody. Today we are going to talk about statistics. There are a number of basic statistics elements in the GMAT exam. They are the concepts of the average, median, arithmetic sequences, um, range, and standard deviation, among others. Well, they are just basic concepts. We are not dealing with very deep statistics concepts like those at university level. So let's begin. Let's talk about first the mean and median. Okay, so when we talk about the mean, we mean actually the arithmetic mean. That is the average of several numbers. And it is defined as the sum of elements in a certain set of elements, and that sum divided by the number or quantity of elements. In most questions, they will always add the word or phrase arithmetic mean in parentheses. Well, that's not really new information, just the way to distinguish the mean, the average of other types of mean. There is also the median, which is defined as the element in the middle position of a number of elements that are already arranged from least to greatest. For example, if we talk about these numbers, for example, 1, 5, 13, 15, 31, and 47. As you can see, this set of elements is already arranged from the greatest, from the least greatest. And if we count the positions, right, we have the first, the second, the third, fourth, fifth, and sixth. There are 6 possible positions here, but there is no middle position because there are an even number of elements. We have 2 elements in the central position, and in this case, the average of these 2 central elements would be 14, and that's a definition of median in this case. The median is the average of the 2 central positions. For example, for another set such as, for example, 2, 10, 22, 46, 70, you can see that if we order these from least to greatest, central position is only 1. And that is the median of the set of elements. So that's a definition of median. Let's talk about the definition of weighted average. The weighted average is an average where the values to be averaged have corresponding weights. They are like coefficients that multiply by the values are added all together. This product of value multiplied by weight are added all together, and then you divide by the sum of weights. Okay? In this formula, you can see how to calculate the weighted average for 2 values with their respective weights. In most cases, knowing the proportion of the weights is enough to know the weighted average. So that, for example, in this graph, you can see the 2 values to be combined, right? Giving an average A, but each of them has a corresponding weight, W1 and W2. Okay, so we can reason in this way, you know, the greater the weight of a certain value is, the closer the distance of the weight of the value to the weighted average. And the lower the weight, then the distance between value and average is greater. So there's like a inversely proportional relationship, right, between the distances or differences of the values regarding the average and the weights of each value. We can express this inverse proportion in this way. Weight of value 1 is to the weight of value 2, such as the distance from the average to value 2 is to the distance from the average to value 1, which you can express simply as the simple difference between here, value 2 minus average, and the first distance would be the average minus value 1, okay? In the case, you know, where the weights of the values are just equal, then the average would be a simple average. All right, let's see an example of how to use this concept. The students in classroom A and classroom B took the same test on a certain day. The average grade of the students in classroom A was 12, and the average grade of the students in classroom B was 18. If the total number of students in both classes combined is 48, the average grade of the students in both classes combined was 16, how many students does classroom B have? Okay, we can use here the concept of the weighted average of two quantities with their respective values. You can do it the graphic way. So you can see, we're trying to calculate the average of two scores, the score of classroom A and the score of classroom 18. And the weighted average, the average of the whole students in both classrooms is reported to be 16, right here. So we know that the distances here are 4 and 2. On the other hand, the weights for the respective scores of each classroom could be considered the number of students in classroom A and the number of students in classroom B. So that in this case, there is a direct proportion or inverse proportion between the weights of the scores and the differences of the scores with the average. So we have NA is to NB as 2 is to 4, which means 1K over 2K. Since we're told the total number of students, that is the sum of these two, right? We're given the sum, 48, but the sum of 1K and 2K, since there is this correspondence, right, would be 3K. And 3K being 48 means that K equals 16. Now, how many students does classroom B have? Well, classroom B would have 2 times 16 or 32 students, and that's it. Okay, so you can see once we found the proportion of the two weights, it's very easy to solve the problem. How would we do this with a formula of weighted average? We could say that 12, the score of classroom A multiplied by its weight, that is the number of students, plus 18 multiplied by the weight, number of students in classroom B, divided by NA plus NB equals the weighted average, 16. So in a cross product, we can find the proportion by doing this, right? 16 NA plus 16 NB, and then now we have NB. 2 times NB equals 4 times NA, and from here again we have that the proportion, right? It's the same, 1/2 or 1K over 2K. And from this, we can solve in the same way as in method 1, right? So these are two possible ways to use that formula of weighted average. Let's now talk about the arithmetic sequences. Arithmetic sequences are sets of elements that increase by the same amount from one term to the next. In the GMAT, you can identify arithmetic sequences from these key phrases on the bullets: consecutive integers, consecutive even integers, consecutive odd integers, multiples of a certain integer from an integer a to integer b, or even integers from a to b, or odd integers from a to b, right? Where a to and b are integers. Okay, what is very important about arithmetic sequences? When you identify arithmetic sequences, they have a unique property regarding their media and the mean. The median and the mean happen to match, okay, in an arithmetic sequence. And because of that, we have a formula for the quick calculation of the sum of elements. Since the mean is defined as the sum of elements divided by the number of elements of a set of values, this is the mean, but at the same time the median. So we have the formula sum of elements is number of elements multiplied by the median. We can calculate the number of elements and the median in an arithmetic sequence with two simple formulas that take advantage of the symmetry of these elements that are distanced evenly, you know, from one another. So for a number of elements, you can identify the last and the first terms of the sequence, divide this difference of them by the common difference between two consecutive terms of the sequence. For example, we talk about consecutive integers, that common difference would be 1. For consecutive even integers, the common difference would be 2. For multiples of 7, from integer a to integer b, the difference would be 7, etc. So the difference of the last term minus the first term divided by the common difference plus 1. And the median is defined as the average of the last and first terms of the sequence. Okay, this is how you can fast calculate the number of elements, the median of this sequence, and just by multiplying these two values, you can get a sum in no time. Remember that even though they're not asking you to calculate the sum of terms in the sequence, you can still consider that every data given or question asked that is an average must be taken as a median. Yeah, median and the average are equivalent in an arithmetic sequence. So let's talk about an example. What's the sum of all the multiples of 9 between 100 and 200? Well, first things first, multiples of 9 between that range of integers means actually an arithmetic sequence. If it is an arithmetic sequence, we can find the sum very quickly by estimating the first and the last terms. So here would be 100 plus something, right? So that we have a multiple of 9. What would be that? We need, you know, you need one sum of digits that gives a multiple of 9, and that would be 8. So 1 plus 0 plus 8 is 9. Okay, this is the first term. What about a multiple of 9 before 200? The closest and before 200 would be 190 plus some digit. And we need this to be like this, right? So if we add 1 plus 9 is 10. So the greatest multiple of 9 would be when y is 8. So 198 would be our number, the last multiple of 9 in that sequence. So now the number of elements, right, of the sequence you can calculate by difference of the first and the last term divided by the common difference, which is 9 plus 1. This is, you know, 90 divided by 9. Okay, here you have 0, 9. 90 divided by 9 plus 1. So that is 11. What about the median? The median is 198 plus 108 over 2. So here you have actually the sum of 6, right? 0 and 3. So 153. And the sum would be the number of elements multiplied by the median, which is 153 times 11, that is 10 plus 1. So 1530 plus 153, 16, 80. Right? 1683. Yes. Okay. Let's now continue with the next concept, which is the range and standard deviation. The range and standard deviation are measures of dispersion. They are used to find out how spread out the values in a set are. For example, the range is defined as the difference of the maximum and minimum values of the numbers. Yeah, this tells us about the extreme values in a set, but nothing about the values in between. On the other hand, standard deviation is similar to the average of the distances from each value to the mean. It takes into account all values in the set for its calculation. For example, here you can see if this straight line the middle represents a mean, so this would represent the differences of all values regarding the mean, right? And if we average the lengths of those segments or the differences between each number, each value, and the average of all of them, then you would have like the average distance of the values to the mean, and that is the standard deviation. Okay? We don't need to use the formula of standard deviation because the GMAT tests only your understanding of the concept and some common structures. For example, one important property is that if all values in a set are equal, then the range and standard deviation are both 0. So it's the only case where you can give the standard deviation of a set even when you don't know the values in the set. On the other hand, if you add or subtract the same value from all of the elements, the range and standard deviation remain the same. For example, you have these values, 1, 3, 7, 9, and 10. And you add 10 to each of them. So you would have 11, 13, 17, 19, 20. These two sets have both the same range and the same standard deviation. Let's see some common structure with the standard deviation that we can meet up with in the exam. When in a problem they talk about a symmetric distribution, this represents a very big set of values where you can represent the way elements are distributed according to their values regarding to the mean of them as a bell shape, right? And the area below the bell shape represents the number of elements in each different range of values. So this means, for example, that half of the elements, right? Half of all elements are greater than the mean. And also, half are less than the mean. So that's the understanding for this diagram. And in this context, when the standard deviation is given you as a number, some GMAT problems, right? They talk about K standard deviations, and they use them in these phrases here. For example, if they tell you that a certain statistical variable x, right, is 2 standard deviations below the mean, what does it mean? Well, it means that the value of that variable would be the mean take away 2 times the standard deviation. So this would be the value of the variable. Okay, that's the structure. K standard deviations below the mean. Now, if they told you that a variable x is 3.5 standard deviations above the mean, it means a value greater than the mean. And the value would be the mean added with 3.5 times the standard deviation. So this would be the value x. There's a third phrase structure using standard deviation that is called within the mean. For example, if a certain problem said that x is a statistical variable that has a value that is 1.5 standard deviations within the mean, they are giving you an entire interval here. So that is to say that the values for the variable are between these two ends. That is to say, x is less than the mean plus 1.5 times the standard deviation, and they are greater than the mean minus 1.5 times the standard deviation. All right, let's see an example of this concept. In company X, the age of 24 is 1.5 standard deviations below the mean of age of all the employees, and the age of 36 is 2.5 standard deviations above the mean of the age of all the employees. What's the mean age of all the employees at company X? Well, we can see that if this is a diagram showing the position of the mean, right? And they tell you that 24 is an age that is 1.5 standard deviations below the mean. So that is to say that the mean equals, right, minus 1.5 standard deviations equals 24, right? On the other hand, if you have 36 years, and that is the mean plus 2.5 standard deviations, well, that simply means that 36, right, equals the mean plus 2.5 standard deviations. Okay, with these two equations, we can quickly solve the mean, but you can also do it graphically, because if you notice here, the whole distance here would be equivalent to 4 standard deviations, 1.5 deviation plus 2.5 deviation, right? But if 4 standard deviations stand for 12 years of difference, so that is to say that 4 times d is 12, then the standard deviation will be 3 years. And you can just replace here, right? So that would be 3. So here you have mean would be 24 plus 1.53, that is 28.5 years. That would be the mean value or mean age.